Hello, today we will be talking about how to find the asymptote of a rational function. Obviously using limits because that's what we're talking about these days. So let's take a sample rational function such as f of x is equal to x plus 2 over x minus 2. So if you need a refresher, a rational function is when you have two polynomials or two functions of x divided by each other, such as in this case. So let's get right into it. First, let's draw a graph just so you know what the asymptotes look like. So this is like the vertical asymptote and this is the horizontal asymptote. So so first let's start with the vertical asymptote because that is so much easier to calculate. So the vertical asymptote basically you just need to use your head, you have to use critical thinking here, and you just realize that in the vertical asymptotes the function is at infinity, right, or negative infinity, it doesn't matter. So you say that limit x to some number b of x plus 2 over x minus 2 is equal to infinity. And we know infinity is equal to 1 over 0. So or anything over 0 for that matter. But because of that, we can also say that because these are the denominators, x minus 2 is equal to 0. So limit x to b of x minus 2 is equal to 0. And we can forget about the top part. Therefore, b is equal to 2, so the horizontal asymptote is x is equal to 2. So essentially, the vertical asymptote is where the denominator, what value makes the denominator equal to 0. Now for the horizontal asymptote, let me write this really quick. Okay, so horizontal asymptote, here it's a little different. Here instead we say that we limit x towards infinity of x plus 2 over x minus 2. Why? Because in the horizontal asymptotes, it touches the asymptote when x is infinity or minus infinity. So that's why we're doing this. And we know that when we have 1 over infinity, that's equal to 0. So our goal is to bring infinity down, to bring x to the bottom, not to the top. So to do that, we can split the fraction over here. So we can say this is equal to x over x minus 2 plus 2 over x minus 2. And then we can just forget about this part because we already have x in the bottom, this becomes 0. So yeah, we can forget about this. So now we look over here, and this is a technique that you all will need to use. So here we can divide both sides, both the top and bottom, by x. So we just make this 1 because x over x is 1 over x over x minus 2 over x. And in this case, we're dividing by x because x is in the numerator and we want to bring it down. So this is equal to 1 over 1 minus 2 over x. X is infinity, so that becomes 1 over 1 minus 0, which is 1. As simple as that. So that's what you do if you have something simple, something simpler, where both of the highest powers on the top and bottom have the same power. Here it's x to the power of 1 over x to the power of 1. However, this changes when you have if the powers change. So for example, if you have x squared plus 2 over x minus 2, or if you have x plus 2 over x squared minus 2, then you get completely different results. So let's look over here. In this case it becomes harder because this is a bigger power. So if we split this, we get x squared over x minus 2 plus blah blah blah, because we don't care about this part. And then we do the division of x squared, so we get 1 over x squared minus 2 over x squared. So we can ignore this part now because this is 0 anyway. But over here we get, what do we get? We get 1 over x. So we have 1 over x now, which is equal to x. Therefore, if the top has a higher power than the bottom, then the asymptote does not exist, because you just end up with this infinity, which makes sense, because like when x is infinity, y is also at infinity. That's what it's saying. On the other hand, here, if you do the same thing, you get x over x squared minus 2 and plus blah blah blah. Then you divide, so you do 1 over x squared over x minus 2 over x. This becomes 0, and this becomes, so now you end up with 1 over x, which is equal to 0. So here the limit will always be the asymptote will always be y equal to 0. So these are the 3 types of horizontal limits that you can use, you will find, and you should really be careful because of these drastic changes. I'm sorry that this video was a long one, but thank you for watching, and I hope it was fun listening to me.